about those chemical names and formula. So in this case, for this question number 20, they ask what's the ratio of the hydrogen to the oxygen. So what you need to do is to mark the oxygen versus the hydrogen. And let's count. So for the hydrogen, you have 12 there, 3 times 4, right? So you have 12, and you have 3 more oxygens there. So you have a 3 because you have the OH group, which is taken 3 times. So this is 3, and 12 are the oxygens on this side, 12. So for a total of 27. For the hydrogen, you have 3 in the OH group, and then you have twice for 12, so you have a 24 over there, which is a 27. So they want the hydrogen, right, to the oxygen. So the hydrogen to the oxygen is 27 to 27, which is the same as a ratio 1 to 1, which will be your choice D. For 21, which of the following compounds would you expect to be ionic? So you have sulfur and fluorine. So that's not ionic because they belong, both of them are in the P group. Sorry. H2O, no, you know that this is a typical Lewis structure stuff scenario, right? And you know that if you're drawing the Lewis structure, you don't have a ionic compound. This is a shared one, so this is covalent, right? Would be ionic if you're transferring those electrons. H2O2, same things, is ionic, and H3 again is ionic. I'm sorry, it's covalent, right? All of those are covalent. This is your NH3. So CaO is the only one because you do have the Ca with those 2 electrons that want to migrate, right? And you have the oxygen instead with those electrons over here. So those 2 electrons will move from here to here. So that will be the ionic compound. So this is the only one. So the choice E is that one. Then, so 22, the charge of the iron. Well, according to the criss-cross, right, you have the iron which has a charge of +3. How else would you know? Well, you know that the oxygen is always a -2. So on this side, you have 3 oxygen, every single one of them with a charge of -2. So if every one of those oxygens contributes with a -2 charge, one second. So you have the Fe2O3. So this means that you have 2 irons, right, and 3 oxygens, right? This is what this formula means. Now here you have 1 oxygen. Every single one of those oxygens contribute with a -2. So -2 and -2 is -4. -2 is -6 on this side, right? This one you have 2 of those. So the only number that you can come up with on this side is 3 and 3, so that you have also a +6 for a total neutral of 0. So the charge on the iron has to be 3, or you just move the 3 up there and you know it anyway. And then 23, what is the formula of the compound formed between strontium and nitrogen ions? So you have strontium and what did we say? Nitrogen. And nitrogen is here. So nitrogen has a -3 charge. What is the strontium? Well, strontium, if you remember, has a +2. So you got to balance those charges. So S3, strontium 3, nitrogen 2 is the one that you are going to choose. So B will be your choice. Next question, which species below is the nitride ion? Nitride. So first of all, it's nitrogen, so it's not sodium, right? And this is nitrate, this is nitrite, this is the ammonia. So this is the nitride because it's the only element, right? According to the periodic table, nitride, I'd come from the periodic table with no help of any other element. So this is the one, and -3. Then, so A is your choice. Then Number 25. Which one of the following compounds is chromium 3 oxide? So you need to have chromium, you need to have oxygen, you have the chromium 3 there. So how do you think about those stuff? So you have chromium. Chromium comes with a charge of 3, and then they say oxide, which comes with a charge of -2. So how many chromium, how many oxygens do you need in such a way that you can balance those charges? Well, you need 3 of those here and 2 of those there. So Cr2O3 is your choice. Cr2O3, so A is your choice. And then 26, what is the correct formula for ammonium sulfide? So ammonium, this is your ammonium, right? This is your ammonium. And then sulfide. So this one has a charge of 1. This one has a charge of -2. So you need 2 of those to make your compound. So C, that's the one. So C is the one that we are choosing. So for number 27, which formula and name are incorrect? So for this one, so I would say, so let's start from the name. Iron 2, so iron 2 sulfate. That would be your sulfate. This is -2, so the formula matches, so that's fine. And then iron 3 sulfide. Iron 3 sulfide, I would write it like that. So you need a 2 there, a 3 there. So that's fine also. For the C, iron 2 sulfide. So you need a 1 and 1. That's what they have. Then they have iron 2 sulfide. That's a sulfide. And this is 2, so ratio 1 to 1. So that's fine. The last one is iron 3 sulfide. So this one needs a 2, this one needs a 3, but they have a sulfate, so E is going to be your wrong choice. So the answer is E for that one. Then for 28, the formula for the compound formed between aluminum ions and phosphate ion is, so PO4 is your phosphate. It has a charge of -3. If you check your periodic table right here, right, your phosphate is with the charge of -3, so it's here, right? And which one are we doing? And aluminum has a charge of +3, so the ratio is fine, but obviously you got to write a 1-to-1 ratio. So B is your choice. Then 29, barium reacts with a polyatomic ion to form a compound with the general formula, which is this, which would be the most likely formula for the compound with the sodium, between sodium, well, that's barium anyway. Okay, so this is the compound with barium. So this is for telling us that your X has to be a -3 for a charge. So with sodium, you need to have a 3 there, so your choice should be D. And then for 30, which one of the following is true according to the simplest unit? Here, magnesium chloride, so 1 magnesium and 1 chlorine gas reacts to form the solid magnesium chloride. So 1 magnesium and 1 Cl2 molecule. But they are talking about the simplest unit. They are not talking about the reaction itself. 1 molecule of this, well, considering that this is ionic, I would not call it molecule. But this is made of 1 atom and 2 chlorine atoms. Well, it's atoms and atoms. You got to have a positive and negative to form a compound. So the best choice would be one positive ion and two negative ions to form your chlorine, because this is magnesium 2 plus and Cl 1 minus. So D is your choice. Mole concept. So 31, the problem to 31 states molar mass of is. So we got to do the calculation. So remember what this means parenthesis wise. So this is just like math. This means that you have 3 nitrogens. So you have a 14 times 3. 14 times 3. And then you have 3 of the H's, but you have 12 in all, so that would be plus 12. And then you have phosphorus to take care of, you only have 1, so plus 31. And then you have 4 of the oxygens, so you have plus 4 times the 60, which is the mass of your oxygen, for a total of 149. So C is your choice. 32, 1 mole of blank contains the largest number of atoms. And for A, you have 8 atoms of sulfur. So 8 is the number here. This is 18. This one instead is 2 here and 3 for the sulfur and 12 for the oxygen. This is 12 plus 3 and 2. So this is 17. Then you have 3 and 4 is 7 and 1 is 8 again. And 2 here, so the highest number is B. So B is your choice. 33. So, and about this number 33, so you do have that many grams of glucose. How many moles are there? So this is a simple stoichiometry problem. So I just copied the same problem again. And so at this point, what you need to do is to basically convert your grams into moles, right? So there's not much else going on. So you have to calculate your molar mass for your glucose. So you say, so the formula is C6H12O6. So according to this, what you do? So you just calculate your mass. So you have 6 atoms of carbon and 12 of 1 gram, which is the hydrogen, and 6 more of oxygen, right? You add them up and you have 180 grams per mole, right? So now you do have your 30.5 grams. And when you use the chart, or you just do it because you know it, this is 180 grams in 1 mole. So gives you a 0.169 moles as an answer. And that means is your answer B. Okay. Then for 34, you have, so how many moles of oxygen are in this formula? So let's copy again this one over here. So then we have the numbers, and so how many moles of oxygens are in that many moles of your carbon? So calcium, I mean. So you got your calcium nitrate, right? And you need 2 of those, so that's what the formula is. So if you have 1 mole of this, because you have a 1 in front of this, right? You have a ratio of 1 calcium to, they say oxygen, right? To 6 oxygens. And you're dealing with, so that's